All right, good afternoon. It's 2 o'clock. Welcome everyone to Unlocking the Power and Benefits of Solar presented by APPI Energy. I am Margot Madden. I'm going to be moderating today, and we are so glad that you could all join us this afternoon. Today, we're going to learn about the current incentives in Pennsylvania for solar. We're going to provide you a better understanding of how solar can reduce energy costs. We're going to gain insights on both the feasibility of solar and ROI, and you're going to leave with a more comprehensive understanding of what's involved from start to finish in large-scale solar applications. But first, I'd like to tell you a little bit about APPI and about your presenter today. APPI Energy is a full-service consulting firm with over 25 years of experience in researching, recommending, and procuring customized energy solutions. Our tenure and expertise in the industry have earned us the endorsements of the Pennsylvania State Association of Boroughs and the Pennsylvania Rural Water Association, along with close to 160 other affinity groups, trade associations, and chambers of commerce. Our goal is to provide comprehensive ways to reduce energy expenses, minimize budgetary risks, and empower our clients to make well-informed decisions. Today, we have Michael Lewis, our Senior Client Advisor at APPI Energy, presenting. Michael entered the renewable energy industry in 2006 when he transitioned from the housing construction industry to installing solar systems on big box stores in California. For 7 years, Michael was an integral part of growing a turnkey solar and racking innovator, helping to grow the solar industry across California and the United States. By 2013, Michael had created his own solar engineering, procurement, and construction firm, engaging directly with solar modular and racking manufacturers, property management companies, and public works entities, building solar projects across the Western United States. After successfully growing his own company, Michael transitioned to the management and development of utility-scale solar farms. Michael's consulted on over 1 gigawatt of utility-scale solar farms, from land acquisition and feasibility studies, off-taker negotiations, design, permitting, planning, construction, grid synchronization, and the long-term operation and maintenance of these assets. Michael considers himself a renewable energy and sustainability nerd. He is a licensed electrical contractor and enjoys reading about everything sustainability and technology related. In his free time, Michael practices hot yoga, runs regularly, and makes time to surf and enjoys getting out into nature. Michael graduated from the College of Charleston in 2003 and resides in Richmond, Virginia. So we are very happy to have him on the APPI Energy team and excited to have him present to you all today. And with that, Michael, I will hand it over to you.
All right. Thank you, Margot, and good afternoon, everyone. Glad to be here. It's nice to meet everyone at PSAB and PRWA. Thanks for the introduction, Margot. We're going to do our best to give you some information here, and we're going to save some time at the end for questions. I'm sure you'll have a bunch of them. Hopefully we cover them during the presentation. We're going to start with installation types. Then we're going to get into the solar project process. We're going to go through a typical solar project timeline. We're going to discuss solar and deregulated energy markets. Then we're going to try to answer some general frequently asked questions. And again, if you have questions at the end, we'll take your questions at the end. Solar installation types. In a broad sense, there are 3 main types of solar installations. You have roof-mounted solar, you have carports, and you have ground mounts. Within roof-mounted solar, you have flush-mounted systems, which are installed flush to the angle of the roof, tilt-mounted systems, which usually require roof penetrations and use some sort of adjustable racking system to build onto a roof. And then you have ballasted or freestanding systems, which is what you'll see in this picture here. Ballasted systems are going to be mostly on flat roofs. It's using stone blocks that are installed underneath the panels. The point of ballasted systems is to remove the necessity for any kind of roof attachments, and it allows for less wear and tear on roofs and allows for not needing a roofing contractor involved in the installation. With ground-mounted solar systems, you have fixed mounted systems, you have trackers. Amongst tracking systems, you have single axis and dual axis tracking systems. Single axis trackers are typically what you're going to see for utility scale solar projects. They're more expensive than a typical fixed ground mounted system, but they'll produce a lot more electricity. That's more of an economy of scale where you're starting to install single axis tracking systems. Dual axis tracking systems are typically way more expensive. You're not going to see as many of them. They were more popular, I'd say about 10 years ago. You'd see more of them. The cost benefit to the amount of operations and maintenance required on a dual axis tracking system doesn't really make it as cost effective. Last type of ground mounted system, and we wanted to mention this, for landfills and for brownfields where you don't want to disturb the earth, solar has come up with ballasted ground mounted systems that don't require any kind of digging into the ground, leaving the surface undisturbed. So that's more of your types of solar installations you're going to see on top of like a landfill or a brownfield. Carports are also, we wanted to mention, carports are going to be more expensive than even ground mounts. Those are your canopy shade structures that you'll see over top of parking lots. They're very pretty. They're very useful, especially in the summertime. They are much more expensive. We wanted to include that. Not included here are floating solar installations. You'll see sometimes pictures of solar panels on top of a lake. Operations and maintenance on something like that is not very effective. But I mentioned that just so I don't get a question at the end asking about a picture you saw somewhere of solar on top of a lake. We're going to move on to the solar project process. And this gives you an idea of kind of where we start and the flow of a typical solar process, solar project. Start with an initial review. That includes what we call a Helioscope review. A Helioscope is a type of software utilized by the solar industry. Helioscope, what it does is it takes an exact location and it allows you to draw an array, a solar installation at any location across planet Earth. It's a type of software. There are other types of software besides Helioscope. We mentioned Helioscope here because it's kind of the tried and true of the solar industry. Helioscope incorporates your historical weather data. It incorporates the irradiance at the given locations, the amount of sunlight that you're going to be able to harvest from the sun at that given location. It factors in soiling, any kind of degradation over time to the solar installation. It takes all this information and it processes it for you in that given location and produces a bulletproof model for your expected output, your expected solar power production in that given location. We take that Helioscope and we analyze that against the utility bills provided for that location. And that comes up, it gives us a very, I'd say plus or minus 8% idea of what solar is going to look like in that given location. There is an amount of shading that's incorporated into Helioscope. If there is interest, if that makes sense, if after an initial discussion, we present what we found and you're interested in next steps, the next step is really to verify shading and electrical connection, the condition of the roof, the condition of the ground, any kind of on-site information that will be needed that would be incorporated into any kind of final proposal process. And then after that site visit, where all that information has been gathered on the site, we can put together a final proposal that includes a bankable 25-year power production estimate and an all-in final cost for that proposed system at that given location. move on. And how to pay for it. Right here, we'll get into some of the incentives that are available in the state of Pennsylvania, and we'll get into some of the other incentives, the federal incentives for solar. Really, like most things, two ways to pay for it: cash or finance. If cash, and I say this, we're going to go through all this because even if it is a nonprofit, even nonprofits, this is healthy. It's good for the industry to understand the economics behind how solar is paid for. For anybody who's purchasing solar, whether it be a third party, these incentives are going to be utilized by that third party. The cash incentives for solar on the federal level, you have the 26% investment tax credit. A good way to understand that is for simple numbers, a $100,000 investment in solar realizes a $26,000 tax savings. So whatever tax liability existed, that $26,000 is applied to that tax liability. That can be rolled over year after year. I think it's a 20-year cap on that. The second incentive, federal incentive, is the 100% makers bonus depreciation. What it does is it allows for that typical maker's schedule. It's usually a 5-year schedule for deducting investments in equipment. That's the same schedule that's used for solar. The recent tax codes have allowed for entities to take 100% of that depreciation schedule in year one of the project. And if there's not enough tax appetite to realize 100% of that bonus depreciation, then what happens is that you can take the typical 5-year maker schedule and take the depreciation over the course of that 5 years. There's one other federal incentive that I felt like would be good for the PRWA members and to understand in general is that it's called the USDA Rural Energy for America program, or REAP grant. And it requires underwriting, and there's a bit of a process to it. The timing for the grant is usually months out, but we wanted to include that, especially for PRWA members, to understand that there is also a rural energy program through the USDA for incentivizing solar. And one other note I wanted to add for the 100% makers bonus depreciation, you'll see about another 26% of the project costs from that additional, the 100% bonus depreciation incentive. So to use that same number, that $100,000 investment, you'd see about $26,000 back from the ITC, and you'd see roughly another $26,000 back from that bonus depreciation. So a $100,000 project in year one has already realized a tax savings of $52,000. State incentives. Pennsylvania, a few of the utilities have been floating the idea of incentives, of direct incentives through the utility companies. Those we were hoping to see those materialize over the last few months after a lot of talk. We haven't seen those materialize yet. We're keeping our eye on those, and we can update you as those become available. Renew RECs in Pennsylvania. So this is the big incentive in the state of Pennsylvania, are called renewable energy credits, or in this case, solar renewable energy credits. And the current value of renewable energy credits in the state of Pennsylvania is $35.50 per megawatt hour. So a system that produces 1,000 megawatt hours in a year would receive a check, and that's paid to that entity for $35,500 in this case. We wish we could model that out with certainty for an extended period of time. With renewable energy credits, that is a floating market. $35.50 is the current market that's being used. That's a pretty widely accepted number or value to those renewable energy credits per megawatt hour. You could model that out for a couple of years with certainty at $35.50. If you're taking a more conservative approach, you understand that that number could go up and it could go down. And we feel like a more conservative approach is to say that it may go down a little bit. So if you'd like some more information on renewable energy credit values or expected values in the future, we can do our best to model that, but it will always be part of a market that is changing. Like I said, rebates depending on utilities. That is in the state of Pennsylvania. There are a few utilities that are floating the idea of incentives, and we thought those would materialize by this point, and they have not. Pennsylvania, the state tax incentives, the current tax code does not allow for income tax write-offs as part of a solar installation. There are some states that have incorporated that into the tax code. Moving forward, there's probably going to be more incorporation of that, and we can include it here because as states have started to adopt that, Missouri, California, we feel like Pennsylvania is a state that will look to do something like that. And last, under cash, we present this idea of an LLC concept. And the reason for that is a lot of the times solar will be owned by a third party holding company if it's a cash purchase. And that third party holding company, it may be a property that is under an LLC and a different business operates at that property, the LLC being strictly some kind of holding company. If the solar is owned under the LLC, then that 100% bonus depreciation, instead of using a typical corporate tax percentage, then you're applying the tax percentage to an LLC, which greatly boosts the incentive possible for that bonus depreciation. Now, to get into how to pay for it, if it's a financed project, we include this first, knowing that PSAB represents a lot of municipalities and nonprofit entities. For tax-exempt entities, a power purchase agreement or PPA is usually the way to purchase solar. In some cases, for very large entities, there's not enough roof space, there's not enough ground space, and then you'll start to look at something called a virtual power purchase agreement. A virtual power purchase agreement is third-party owned, negotiated distribution transmission charges with the utility company through that third party. The entity enters into an agreement with that third party to be the off-taker of the electricity, the kilowatt hours that are produced at that location. And all of those kilowatt hours produced at that location are then applied against the utility bills, the electricity bills for that entity, wherever that physical entity and its electricity bills are located. There are finance options for lease to buy. There are solar loan options. In some cases, customers just create their own solar loan. They go to a third party and they're going to get a better interest rate from their own bank. So they'd rather engage their own bank and finance solar themselves. Another way to finance solar is called on-bill funding. And what it is through several of the suppliers for electricity, large suppliers across the United States, especially in Pennsylvania, in deregulated energy markets. They have programs where the funding for solar is funded through payment of the electricity bills and in some cases gas bills. And those payments come off of are part of the electricity bill that entity would be paying on a monthly basis. All financial modeling for solar, pro forma modeling, is based on 25 years, which is the power production warranty period of solar panels themselves. So solar panels have a pretty much industry-wide 25-year warranty on solar panels. That comes with typically a 0.5% of degradation built into that warranty over the course of 25 years. And most modeling, if not all modeling for solar, is going to be based on 25 years. Sometimes you'll see it for 30 years, but typically industry standard is going to be a 25-year model to mirror the warranty of the actual solar panels themselves. On our end, we stay in contact with the customers throughout the final proposal contract agreements. We're included in the entire process. We're here to answer questions, and we make ourselves available to be a part of any kind of solar process for any of our customers and partners. I want to go over the solar project timeline just to give you an idea of the process and what to expect. And this varies quite a bit, but for the initial designs of solar, you're looking at projects that are going to need an electrical engineer's stamp. They're going to need a structural engineer's stamp. The process of putting together that final design package can take anywhere from 2 to 3 weeks, depending on availability of material. Material being maybe you might have plans for the roof, maybe you might have surveys that have been done of land where there's going to be a ground mount. That any information that can be provided is going to help the process and further it along so that the engineers can put together their design package. The utility interconnection process, once that final design is put together, there's an interconnection process that's part of a package that's submitted to the utility company. The approval or conditional approval of that interconnection can take anywhere from 1 week to up to 10 weeks in some cases. It depends on the utility. It depends on the how busy the utility is. And anywhere across the United States, you're going to see some utilities that will respond in 1 day with an email back that says this is conditionally approved for interconnection. You can move forward to your permitting process. In some cases, they require a full review, an engineering review. Especially if you're looking at a much larger installation, you're speaking of something of almost the utility scale size, that process is going to take quite a bit longer. And we can discuss that further when you have some questions, or we can take that to another conversation. Permitting process, again, is anyone's guess. In some areas, it can take only 2 weeks. I've walked into permit a large project and was able to do it over the counter. In some cases, I've submitted for a project and not been able to get a permit for over 3 months. We include this timeline to give you an idea, not to tell you exactly how long it's going to take in your particular area. The physical installation process, that's going to take anywhere from 2 to 6 weeks. Again, if you're talking about a large ground mount of utility scale size, that process could take longer. But 2 to 6 weeks, if you're talking a roof mounted installation, a small ground mount, that's typically going to be your 2 to 6 week timeline. Your final inspection and syncing power to the grid can take anywhere from 1 to 4 weeks. The timeline being there are some utilities that require additional inspections from the utility. Sometimes you have to set up those inspections. They're not exactly waiting around for you to call. They have busy schedules also, so it can take upwards of a few weeks to get that person out there to do their final inspection. And then after that final inspection is done, typically there's a process where you have to get the approval back from the utility inspector or building inspector. And then once you have that in writing from them, then you are okay to turn on the system and start producing power. At that point, you're going to have monitoring on your system. You're going to be able to view your system in real time. You're going to be able to measure production of your system based on what the metrics were presented to you in the proposal, and be able to set little parameters inside of the monitoring system to be able to identify any kind of aberrations to the production of the system. You'll be able to see when clouds go over and the system goes down for a minute and then spikes back up when the clouds are gone. It's interesting and it's fun to watch. Next, we're going to get into a little bit of just give you a little bit of bullet points for stuff to understand with solar. Operations and maintenance is something that a lot of companies don't present up front when they're presenting solar. There's not a whole lot of operation maintenance that goes into solar, but asset managers, large asset managers especially, have realized over the years that it is worth the cost and worth the time to do a system check once a year at least. Some of them do that every 6 months. On large utility scale projects, they're always doing operations and maintenance. There's asset management going on all the time, every single day. Inverters are your real moving part with solar. If you talk about something that is going to fail in a solar project, it will be the inverters. You can bank on between years about 11 and 16, the inverters will fail. So if you're looking at a proposal for solar and it doesn't show a line item for in years 11 through 15 or 16 having to replace inverters, that's something to keep in mind. You will need to replace those. There will be a cost for those. Inverters are warranted for 10 years. So if an inverter fails or there is an issue with an inverter over the course of the first 10 years of the lifetime of the system, your operations and maintenance team should be able to come out, your solar company should be able to come out and service that inverter. In most cases, I'd say it's almost as simple as turning the inverter on and then back off. And then in some cases, you need to just cycle it a couple times. Like I said, you're turning it off, you're turning it back on, it'll turn itself back on. In other cases, there's something to troubleshoot, and it usually is a fix within a couple hours. If it does need to be replaced, if it's a catastrophic failure to the inverter, then what'll happen is that inverter will get replaced within those first 10 years. They send a new inverter, the old one goes into the box back to the inverter manufacturer, and the new inverter is installed back on site. Let's see. In some cases, you'll see inverters last up to 20 years. Not as common, though. I've seen that. I've seen an inverter from 1990 from a really old system that was still operating in year 2015. So you never know. It's really it really is anybody's guess. But most inverters you can bank on, as far as from a cost perspective, having to replace them between years 11 and 16. Panel washing, and we included this slide because a lot of people have questions regarding panel washing. In Pennsylvania, in the southeast, in the northeast, there's so much precipitation that panel washing isn't really something that you need to look at as a big generator of increased electricity. It starts to become cost effective for systems over 1 megawatt in size, and you'll see that for utility scale projects, they'll budget in an amount for panel washing for utility scale projects. For your typical ground mount, your typical roof mounted installation, especially somewhere like Pennsylvania, consistent precipitation makes it so that panel washing really isn't going to be cost effective. Out west in California, there it's going to be cost effective. They don't get precipitation. If you're doing a project in Nevada, if you're in Arizona, if you're somewhere that has these months of dry, no precipitation during the year, then the financial payback for something like panel washing really starts to make sense. We wanted to include that just so we get ahead of that question, and because a lot of people have questions regarding panel washing for solar. Next, we'll get into what really is going to matter for this conversation: solar and deregulated energy markets, and Pennsylvania being a deregulated energy market. And there are things to consider and things that APPI has learned through our process with solar. There are a few clauses that you need to keep in mind with regard to supply agreements and solar. You need to look for 100% swing, no adverse material change clauses, no on-site generation clauses, and net metering. And we include this because that's our APPI has been in this market for 25 years. We have a considerable amount of experience with regard to solar in deregulated energy markets, and suppliers do include this kind of language in their supply agreements, and it handicaps the ability for entities attempting to invest in solar because they're in a supply agreement that includes these types of clauses. We're going to get into net metering a little bit because that's really the bread and butter of solar. And again, there are even though net metering is a policy, it is a law that allows solar to be effective as an alternative source of electricity for grid-tied commercial entities, municipalities, for any kind of entity that, even a house, everything that is installing solar. Net metering is a lot of what makes it cost effective. Now, we've realized that you need to be careful with net metering because even though it is a law, especially within the state of Pennsylvania, supply agreements, third-party supply agreements will include, in some cases, language that don't allow for net metering. And APPI has run into that. That is something that I can tell you, having installed solar for 16 years, was something that was relatively new to me, and I would never have thought of it. And speaking with other solar companies across the United States, they've had quite a few issues with regard to net metering and solar. Net metering, what it does is it's a one-to-one value for the kilowatt hour credits that are produced by the solar installation. So the solar project will, in some cases, overproduce electricity during the daytime, and that electricity is being sent back into the grid. And during the nighttime, that entity or that electrical panel, that building, whatever it is pulling electricity from the grid. And what net metering allows for is the one-to-one value of those credits that have been sent back out to the grid during the daytime. When they're used back up during the nighttime, they're one-to-one value. So if you're paying 10 cents for a kilowatt hour and you overproduce during the daytime, those kilowatt hour credits that are coming back to you that you're now pulling from the grid, you're getting exactly 10 cents value for the value of the credit that you sent back into the grid during the daytime. We've realized that it's another particular thing that needs to be reviewed within supply agreements. We're very careful about that. We're very careful about all these things, the 100% swing, looking for material adverse change clauses, looking for no on-site generation clauses, and especially net metering. And I wanted to show a quick idea of why this is so important, and a few slides here, just to give you an idea of the way net metering works with regard to electricity bills. So you see here on this utility bill, you'll see that net meter banked usage information. And this is fascinating, and this is a perfect example of net metering in action. So what you have here is delivered up here for usage information. This delivered 2,691.5 or 2,692 were the amount of kilowatt hours that this utility company delivered, or this supplier. This is a supply, part of a utility bill from a supply agreement. This here is the amount of kilowatt hours that were delivered to this entity during this period. And then right here, received are 11,230. These are the amount of kilowatt hours that were received into the grid from the solar installation. So here you'll see current month kilowatt hour deposit, 11,230 kilowatt hours. And then right here, the withdrawal credit of 2,692. They rounded up from that half a kilowatt hour. We'll give it to them. And then banked, you have the remaining amount, 8,538 kilowatt hours are sitting there remaining. So the next month's bill will immediately have this banked amount, and any kind of additional consumption at that location will automatically first need to withdraw from these banked kilowatt hours that are remaining. We thought this was a good example, and I'm glad we had this available to show everyone. Here, wanted to include this. This is a typical kind of bar graph showing solar generation, expected solar generation at this location versus the monthly energy use of that location. So what we did here is we took the electricity bills from this entity and we created this bar graph. And then the next thing we did is we took the expected kilowatt hour solar generation along the course of the year and put the two on top of each other to give you an idea. This is a great example of not necessarily net metering, but what this gives you an idea is why it's so important to be very conscious of supply agreements and deregulated energy markets with regard to solar. You can see here, this is not going to cover, the solar is going to cover about 45% of the expected usage at this location. And you can see here, these are the summer months. It's going to produce much more electricity. You can see where there's less irradiance and probably a lot of issues with weather patterns during the wintertime. They're going to reduce production during the wintertime. But this is a great example to show you, in this case, this supply agreement will have to include all those, it will have to be reviewed to make sure that it doesn't include any clauses that make it difficult for this customer. And the second slide, this is a great one for net metering. And what you see here is this is your very standard solar installation bar graph. And you can see this curve here of the overgeneration or overproduction from solar during these summer months. And these credits, these net metered kilowatt hour credits that are being accumulated here in these summer months are going to apply against these months here, these shoulder months of the year. Especially you see in this location, they're going to get a lot of weather in January and February, a lot of weather in November. And what happens is all these kilowatt hour credits, where you saw those credits, those bank credits on that previous utility bill, those are going to be applied in these months here so that they're not going to see a utility bill necessarily for dollars. What they'll see is a bill similar to what you saw previously, where those net metered credits are now going to apply against these months when there isn't enough sunlight or there's a lot of rain, there's a lot of snow, and the solar isn't able to produce as much electricity, but you've overproduced in the summertime, and now because of net metering, all those credits are going to be applied against these months. So we'll get into some general frequently asked questions, see if we can cover some of your questions here, and then we'll open it up to some questions afterwards. So misconception with solar, big question, do solar systems produce electricity when the grid is down? And your standard solar system will not produce electricity when the grid is down. So if you lose power from the utility and you do not have a battery system, the solar will turn itself off. Battery energy storage systems are needed in order to keep a solar installation, a grid-tied solar installation. Now, off-grid, obviously, you don't have the utility. But for grid-tied systems, you need something to be able to communicate that with the solar inverters. And with battery energy systems, you have battery inverters that are talking to the solar inverters and tell them, in a sense, the grid is down, but now we're the grid over here. And it produces the same frequency as the grid. And then in that communication, in that frequency, the inverters themselves now understand the battery inverters as producing that same frequency as the grid. The solar inverters will turn themselves back on, and now they'll be able to produce electricity again. The communication between the solar inverters and the battery systems, there's AI on top of that that helps in that communication and then helps dictate where the solar is going to be sending electricity, if it's going to be sending it to the batteries now to fill up the batteries, or if it's going to be sending it to the building. That's done through artificial intelligence. Can roof-mounted systems be freestanding? Yes, and I covered that a little bit. Roof-mounted systems that are self-ballasted, called freestanding systems. These have those blocks that are laid underneath the solar racking trays. This avoids roof attachments. It avoids the necessity to put any holes in a roof. Slip sheets are pieces of like-for-like roofing material that are laid underneath the racking so that this racking system does not sit directly on top of the roof membrane. In a lot of cases, you're going to have a roof warranty in place. What's done is typically, in order to keep the roof warranty in place, this like-for-like roofing materials will be purchased through that roof warranty holder, that roofing company. And then the solar installation will be installed with pieces of that like-for-like material placed underneath the system, underneath the racking system, so that that racking system isn't sitting directly on top of the roof membrane, so that the roof warranty can be held in place. And now the self-ballasted system has reduced the necessity to put any kind of any kind of holes in the roof. You're going to see self-ballasted systems sometimes have a couple roof attachments. That's more in your areas that are going to have really strange, either really weird wind patterns, but more than likely you're only going to see that in areas that have seismic requirements. Seismic requirements aren't going to be necessarily in a lot of areas around here. You're going to see them in California out west, where you're going to have more seismic requirements. You're going to have regular earthquakes. Then you're going to need roof attachments designed into even a ballasted roof system. How long do solar systems last? Typically, you're going to be 25 years, and that will be for the power production model will be, and most proposals will be for 25-year life cycle of solar systems. Sometimes 30 years. Solar panels will continue to produce electricity for up to 50 years. And I've actually seen solar panels that were from the NASA early satellite program. We were able to get our hands on one of those, and we held it up to the light, and it shocked me. And that thing was probably from 1960. So they will produce electricity for a long time, but the bankable model for solar is going to be 25 years, in some cases 30 years. Inverters, I explained a little bit about inverters. 10 years is going to be your warranty for inverters. You can pay for an extended warranty with inverters, but a lot of people don't do that. They don't see the cost benefit to it. In a lot of cases, the cost of the extended warranty for an inverter will be the same as the cost for the replacement of that inverter. What happens if it snows? Is a great question. A lot of people ask this question. Once the sun comes up and the photons from sun are hitting the snow and ice, or coming through the snow and ice onto the PV cells, the photovoltaic cells of a solar panel, the process that produces electricity starts, and the cells themselves start to heat up. So even in extreme cold, you'll start to see snow and ice melt off of solar panels. In most cases by noon, 1 o'clock on a given day, depending on how much sunlight you have. Now, if you're talking extreme cold for multiple days and feet of snow, it's going to no longer produce electricity. It's buried underneath snow. That said, the great thing about using software as your tool for modeling solar is that the historical weather data is built into the software. So you're going to be able to, what the software does is once you put that location in, it identifies the historical weather patterns going back however long that is, in some cases 100 years, in some cases 60 years, in some cases 150 years. For Pennsylvania, you have historical weather data for over 100 years. So those numbers and the amount of days of snow, how much snow, the amount of days of rain, how much rain, that's all built into the historical model. So you don't really need to worry about that as far as if you do have, you're going to have an anomaly, because anomalies happen. You're going to have 3 feet of snow at some point. That's going to happen. Those anomalies are already built into the historical weather data. So we're talking over the course of 25 years. We're not talking what it's doing today or potentially this year. It's all based on a 25-year model. Why go solar? There are several reasons. Some of them are to meet environmental and sustainability goals. We can help track those. The great thing about even the historical models that are produced in the bankable models, the software will tell you how much CO2 is going to be reduced, the equivalent to number of cars off the road, the equivalent to the amount of trees planted. There are quite a few metrics that will be included in modeling solar, and can help you kind of measure some of those environmental and sustainability goals. Another reason is to hedge current and future costs of electricity. We've seen costs of electricity rise as we've seen the cost of everything rise. Gas prices have gone through the roof. We can install solar and it hedges your cost of electricity for the future. And that's another reason why people go solar. Taking advantage of tax incentives make the timing right for in a lot of cases. Current tax incentives are going to be in place until December 31st of 2022. Then the ITC steps down to 22% unless there's an extension of that investment tax credit. So the other thing is a lot of companies, a lot of entities have been profitable over the last couple of years, even though we've been dealing with the coronavirus. And some of those entities, a lot of those entities have decided that the timing is right to take advantage of those tax incentives, hedge future costs of electricity, and gain the environmental and sustainability goals all at the same time. And another thing to include is that those in tax incentives, even if you're working with a third party who's doing something like a power purchase agreement, those tax incentives are going to be utilized by that third party. So your cost of electricity from that third party or that power purchase agreement for the solar is going to include all those tax incentives, is going to keep the cost down. The other reason people go solar in some cases is to have energy independence. In my own experience, especially in a state like California, where they've seen radical price increases in the cost of electricity over the last few years, something like solar has given them the independence to be able to separate themselves from those cost increases and from the utility. What do I need to know about batteries and energy storage? Batteries give you backup power. Energy storage, one way to pay for it is through reducing demand charges. So artificial intelligence on battery energy storage systems, the controls are that artificial intelligence. And what it does is it's looking at the consumption from the building, the demand from the building, and it's looking at the solar that's being produced. And what it does is sometimes if it sees demand start to spike, what it will do is it will release the batteries. It will release those kilowatt hours from the battery to that entity so that the demand doesn't spike. And where you see high demand charges in places is one way that customers have invested in battery systems, because they see such high demand charges. Now they have a way to use a battery storage system to basically eliminate those demand charges or flatten them. It's called peak demand shaving in some cases, where you see reduction in those peaks in demand by the incorporation of these battery energy systems. The thing about battery systems, though, is that they are still very expensive. So in states like Massachusetts, Connecticut, and especially California, you have incentives for battery systems. In Pennsylvania, there are not incentives for battery systems. The cost effectiveness of them versus something like a generator are not there. But that's not to say it won't be there. And as batteries reach more scale of production, there are more vendors, there are more entities that are manufacturing batteries, you'll see the prices continue to go down, and that cost effectiveness will start to get better and better. What do I need to know about EV charging stations and solar? A great combination for residential and commercial systems if you're talking about level 1 and level 2 chargers. So level 1 chargers are going to be your 120 volt or your 240 volt car charger that somebody has at their house. If you have solar on the roof of your home and you have a level 1 charger, then fantastic. You can basically produce your own electricity from the solar, offsets a lot of what you're pulling from the batteries. Maybe not all of it, but a portion of it, and just makes the whole financial model that much better. Level 2 chargers are your slower commercial chargers that you'll see installed. You'll see like 4 of them maybe at a commercial entity, and it's tapped into the same electrical panel as that entity. So if you're putting solar on the roof of that entity and you have a few of these chargers out front of the place, then you can offset those chargers with the solar production from the roof. Now, your fast chargers are going to be your level 3 chargers, and those require an additional utility meter. So you're not necessarily going to be able to pull the electricity for a level 3 charger from that entity. In a lot of cases, what is going to happen is you're going to need a study done with the utility. They're going to look at the transformer that's on that property, transformer being that very large green thing that hums that's out back of the facility. And they're going to look at that. They're going to look to see if they can tap off of that. It's going to require, in a lot of cases with this new meter, a big stand-up electrical panel. So you have a new electrical panel, new utility meter, and you would have to install a different solar installation to offset that meter at a level 3. And we're talking, this is for a level 3 rapid charging station. What do I need to know about solar system pricing? So typical roof mounted solar systems are going to cost about $2 per watt DC. In solar pricing, we typically talk about, for commercial entities, cost per watt DC. DC is direct current. Solar panels are always, you're going to see them as maybe 400 watts or 450 watts. That's 450 watts direct current DC. The inverter is what's converting that direct current to alternating current, which is what we use in the grid. Alternating current then can be used within your building and anywhere. So $2 per watt DC. So that means a 100 kilowatt system would cost $200,000. Prices vary depending on the specific type of solar installation and economy of scale. So obviously, if you're talking about a utility scale solar farm that's 100 megawatts, then it's not even going to be $1 a watt, but it's 100 megawatts. So you're talking a $85 million project. That's a totally different scale than what you're considering for a 100 kilowatt project on a roof. And economy of scale is a big factor to the cost of obviously everything, but with solar, it's a huge factor. And ground mounted systems, and especially carport solar systems, are going to be the most expensive types of solar projects. With solar, we can get very creative with different places to put solar. Carports are the most expensive form of solar besides those floating solar arrays. I'm not a big fan of the floating solar arrays. I'll be very honest about that. I think operations and maintenance wouldn't be very good on those. And carports are a great option, though you have to keep in mind that the cost will be much more for those. A ground-mounted solar installation is always going to be more expensive than a roof-mounted solar installation. But again, if you're looking at economy of scale, 1 megawatt ground-mounted installation is going to be right on there on par with $2 a watt. Same you'll see for your typical roof-mounted solar installation. So with that, we've come to the end of our presentation. If you'd like to contact me with more information, more questions, my contact information is here. Maybe we can email that out afterwards. I'm happy to answer questions at any time. And like Margot said, I've devoted a good portion of my life to solar. I love talking about it. I love discussing it. So any questions, even anything you have as a question, I'm always happy to answer it, and to the best of my ability. And with that, I'll turn it over to you, Margot.
Great. Thank you, Michael. Fantastic. That was a ton of information. So we will certainly make sure that everybody receives some follow-up for this. We do have a couple of questions before we get to them. And please, if you have any questions, please go to the chat function. It's the little chat bubble up top, and you can type right in there, and I will read those out in just a moment. I wanted to make sure that the group here is aware of the fact that APPI Energy is able to assist your borough or your rural water with the facilitation of solar. So the way that we're doing that can happen in a few different ways. If you're able to just choose a solar provider, we have several that are located in Pennsylvania, also along the Mid-Atlantic, and we have some national providers as well. And we're able to take a look at your location and any specifications that you're interested in, and we can connect you with a match. We understand that in your space, municipality space, oftentimes you have to put out an official RFP. With that, we are able to assist you in an advisory services capacity, and we can help not only write, but help you execute an RFP that is open to the public, and we can help you choose a provider that will work for your needs in an agnostic way. So please keep us in mind there. And then with that, let's see, Michael, we have a couple questions here. Carl would like to know, how does the system work when the grid goes down, but you have an emergency generator?
Yeah, that's a great question. So you can incorporate solar with an emergency generator. There are amount of controls that you need to implement in order to make sure that the solar, and in some cases you have to add an inverter, depending on the functionality of the generator itself. If it's newer generators, they've gotten creative with that ability to incorporate functionality, so that it can work and communicate better with solar inverters. But if in some cases you'll need to add an inverter, and the generator replaces what that battery system inverter would be doing. But it's possible, Carl.
Great, thank you. We got another question here from Cheryl, but I think this is just a general statement that we should put out there. You know, cost, you did add, Michael, how much it costs per watt. Obviously, most people aren't able to calculate that on their own. So I did want to mention here, if you're interested, please send Michael an email directly. We have the capability to do an initial model of solar for you through a software application that we have combined with Michael's expertise. And we can get you in a good general range of what a proposal would look like if it was being provided to you by, a solar design build firm. So please reach out. We're here to answer any questions as the endorsed energy managers of the Pennsylvania State Association of Boroughs and Pennsylvania Rural Water Association. You know, it is a member benefit to be able to be in contact with APPI Energy. So, you know, even if you're not ready to take the next step or you're unsure, we are here to answer any questions at any time. Looks like we got one more question in from Rob. It says, what are roof pitch limits for ballasted systems?
Yeah, it's a good question, Rob. It depends on the wind zone. Obviously with structural engineering, you have different wind zones. I'd be real careful there. I typically, historically, would only model a ballasted roof system for a flat roof. Obviously, no roof is completely flat, so there are undulations to roofs. But that said, if a roof is more than a few degrees, and I'm talking 3 degrees, 4 degrees, even I would start to look at, you're going to have to put roof attachments in. But you can get creative. If you have to put roof attachments in, maybe you can do a combination of working with a structural engineer, because there is a design process. Maybe you can do a combination of roof attachments with some kind of ballast, so that you're eliminating the number of roof penetrations to that roof. But as a rule of thumb, I would just, if it's not a flat roof, I wouldn't, in my own opinion, I wouldn't bank on being able to do a ballasted system. Hopefully that answers that question.
Great. We've got one more from Joanne. What are examples of a ballasted can you give? For example, is a PVS mounted with clips onto a standing seam roof? Is that a type? I think.
Well, yeah, she's speaking of, so S-mounted clips are, when you're talking about a standing seam metal roof, you're going to have these clips. They're manufactured by a company called S5. It'll be a giant S and then a 5 and then an apostrophe, or excuse me, an exclamation point. S5 Solutions, they've been around for years. Really nice folks over there, family-run business, unless they probably sold it at this point. But they manufacture a product that is, it's 2 little Allen screws, or maybe 4 Allen screws. They go right on top of standing seams, and then the racking is built on top of those S5 clips. So you don't have to make any penetrations to a standing seam metal roof. You can use those S5 clips and build the racking on top of those. So you don't need ballast, you don't need roof penetrations. Standing seam metal roofs, because of again, solar folks have been very creative over the years in creating ways to get around issues. Obviously, roof penetrations are something we've tried to avoid. Standing seam metal roofs, great installation opportunity. You've used, and S5 isn't the only manufacturer of clips for standing seam metal roofs. There are lots of copycats at this point. I mentioned them because they were the first, and in my opinion, the best product for that application.
Great. We have another one, Michael. It says, is a 0.5% degradation per year for the solar collector a common rule of thumb?
Yes. Most warranties will have 0.5% per year for solar panels. Some manufacturers, like the most expensive manufacturer, but the kind of the top of the line, if you will, the Rolls-Royce is SunPower, and SunPower has a 0.25% per year degradation as part of its warranty. They charge a lot more for their panels though, so it's unless you're space constraint, you're trying to squeeze as many kilowatt hours into a certain amount of area, you can find a less cost or a less expensive solution. Small commercial, SunPower is a great opportunity or a great company to use because of their ability to squeeze kilowatt hours out of a smaller space. It's the most efficient panel on the planet. That one is the only one, to my knowledge, that has that 0.25% degradation per year. Most other manufacturers have 0.5%, 0.5% degradation per year.
All right, great. Any other questions? Okay, doesn't look like we do at this time. So thank you, Michael, and thank you to PSAB and to PRWA. We appreciate the partnership. We will get out this slide deck so that everyone is able to review the information. And of course, if you have any questions at any time, if you have a proposal in front of you, if you want us to review anything, we are here to assist. So thanks so much and have a great rest of the week.